Hello, and welcome to CCIJ-TECH Hub. I'm Alex, your host for today. We're taking a fascinating journey into the electromagnetic spectrum, the invisible waves that power our modern world.
Hi everyone, I'm Jordan. From AM radios to 5G networks, we'll unpack how these waves connect us all.
And I'm Taylor. I'll be throwing in fun facts and technical details to keep things interesting.
We're talking about the very fabric of our wireless communication, the technology that allows us to send instant messages, share videos, and even beam ourselves across the globe, virtually of course.
Let's dive right in.
We begin our journey at the lower end of the spectrum with extremely low frequency waves, or ELF.
These waves are perfect for a very specific type of communication, talking to submarines deep beneath the ocean's surface. ELF waves can penetrate the depths and reach these underwater vessels.
Generating these ultra-low frequency waves is no easy feat. We're talking massive antennas, sometimes spanning kilometers.
And here's a fun fact. Our own planet Earth generates its own ELF waves. These natural emissions are caused by lightning strikes. Scientists study these signals to learn more about Earth's atmosphere and the global electric circuit.
So the next time you think about the vastness of the ocean, remember the silent whispers of ELF waves, connecting us to the hidden depths.
It's a reminder that even in the most remote corners of our planet, the invisible forces of the electromagnetic spectrum are hard at work.
ELF waves help safeguard our world, carrying messages that help us understand and protect our environment.
Moving slightly higher on our electromagnetic spectrum, we encounter very low frequency waves, or VLF.
These waves excel at long-distance communication, especially across vast stretches of water. VLF waves changed maritime navigation by setting up powerful VLF transmitters along coastlines. Ships equipped with VLF receivers can pick up these signals, even from thousands of kilometers away.
VLF's usefulness doesn't stop there. These waves are also vital for aviation, particularly for long-distance flights over polar regions.
Scientists use VLF waves to study the Earth's ionosphere, the electrically charged layer of our atmosphere. By analyzing how VLF signals bounce off the ionosphere, researchers can learn about its density, temperature, and even how it's affected by solar storms.
VLF waves are the unsung heroes of long-distance communication and scientific discovery.
They remind us that the invisible world around us is full of possibilities, waiting to be explored and harnessed for the betterment of humanity.
Whether it's guiding ships, keeping planes on course, or unlocking the secrets of our upper atmosphere, VLF waves are indispensable.
As we journey further up the electromagnetic spectrum, we arrive at the realm of low frequency, or LF waves.
LF waves have found a unique and crucial niche in our modern world, keeping the world's clocks in sync.
Around the world, specialized radio stations transmit time signals on LF frequencies. These signals, often encoded with atomic clock precision, act like invisible metronomes, regulating the rhythm of our technological civilization.
LF waves also play a vital role in navigation systems, particularly those used for long-range navigation. LORAN, for example, is a land-based radio navigation system that relies on LF signals to provide accurate location information to ships and aircraft.
And let's not forget about the role of LF waves in AM radio broadcasting.
So, while they might not be as flashy as some of the higher frequency waves, LF waves are the unsung heroes of global timekeeping, navigation, and communication.
They remind us that sometimes the most important things in life are the ones we take for granted.
LF waves keep our world running smoothly, ensuring that everyone is literally on the same page when it comes to time.
Chapter 4, Medium Frequency, MF, the Golden Age of Radio.
Occupying the space between 300 kilohertz and 3 megahertz, MF waves were the pioneers of mass communication. Alex, imagine a time before television, before the internet, before smartphones. MF radio was the soundtrack of everyday life, a window to the world outside, a source of information, entertainment, and companionship. Alex's families would gather around their radio sets, listening to news bulletins, radio dramas, comedy shows, and music. The iconic crackle of AM radio, the voices of legendary broadcasters, the shared experience of listening to major events unfold in real time. Alex, even today, MF radio remains an important part of the global maritime distress and safety system. So the next time you stumble upon an AM radio station, take a moment to appreciate the legacy of MF waves.
Chapter 5, High-Frequency HF Bouncing Off the Sky.
Operating between 3 and 30 megahertz, HF waves possess a unique ability. They can bounce off the Earth's ionosphere. Alex, instead of traveling in straight lines like most radio waves, HF signals can take a giant leap off the ionosphere. This characteristic makes HF radio the go-to choice for shortwave radio communication. Alex, from remote research stations in Antarctica to disaster relief efforts in remote villages, HF radio provides a lifeline of communication. And let's not forget about the passionate community of amateur radio operators, affectionately known as hams. Alex HF radio also plays a crucial role in over-the-horizon radar systems. So, the next time you hear the faint crackle of a shortwave radio, remember the power of HF waves. As we ascend further up the electromagnetic spectrum, we enter the realm of very high frequency, or VHF.
Operating between 30 and 300 megahertz, VHF waves have become synonymous with high-fidelity audio and video broadcasts.
The FM radio station you listen to in your car, the television channels you watch, and even the cordless phone you use, all rely on VHF waves.
Unlike lower-frequency waves that can bend around obstacles, VHF signals generally travel in straight lines.
This line-of-sight characteristic allows for greater channel capacity.
This is why FM radio offers a wider selection of stations and superior sound quality.
VHF's clarity and reliability make it ideal for communication in situations where clear, uninterrupted signals are paramount.
The ability to transmit and receive crystal-clear voice communication is crucial for maintaining order and safety in the skies.
So the next time you enjoy the clear sound of your favorite FM radio station, remember the power of VHF waves. Get ready to enter the realm of ultra-high frequency, or UHF, a band that has revolutionized the way we communicate.
Operating between 300 megahertz and 3 gigahertz, UHF waves have become the backbone of our wireless world.
Your Bluetooth headphones all rely on UHF waves. Your Wi-Fi router, your mobile phone.
These waves are short enough to be easily transmitted and received by compact antennas.
UHF's ability to carry large amounts of data over short distances has made it the driving force behind the mobile revolution.
And more? GPS navigation, satellite communication. It's also used for television broadcasting. But UHF is more than just about mobile phones.
Wi-Fi operates in the UHF band using specific frequencies to transmit and receive data wirelessly.
So the next time you make a call on your mobile phone or browse the internet, appreciate the power of UHF waves.
They are the invisible threads that connect us in the digital age. As we reach the upper limits of our journey through the electromagnetic spectrum, we enter a realm of incredible frequencies.
This is the domain of super high frequency, SHF, extremely high frequency, EHF, and beyond.
SHF and EHF waves are the workhorses behind high-speed data communication and satellite communication.
But it's important to remember that our journey through the electromagnetic spectrum doesn't stop there.
Beyond EHF, we enter the realm of infrared radiation, the invisible heat we feel from the sun or a warm stove.
And then, of course, we have visible light, the tiny sliver of the electromagnetic spectrum that our eyes are tuned to perceive.
All the colors of the rainbow, the breathtaking beauty of a sunset, the twinkle of distant stars, all of it is just a tiny fraction of the electromagnetic spectrum.
The electromagnetic spectrum is a continuum, a seamless tapestry of energy, and we've only just begun to explore its full potential.
And that wraps up our journey through the electromagnetic spectrum.
We've traveled from the ultra-low frequencies that penetrate the ocean depths to the ultra-high frequencies that power our wireless world.
These waves, invisible to our eyes, are the unsung heroes of our modern world.
Thanks for tuning in to CCIJ-TECH Hub. Don't forget to like, share, and subscribe for more deep dives into technology.
Keep those minds curious, and remember, there's always more to discover just beyond the visible spectrum.